So this is a parabola. Now, this is a fancy mathematical definition that you probably haven't seen before, but this is what mathematicians mean by a parabola. It is the set of all fixed points on a plane that are equidistant from a fixed line, the directrix, and a fixed point not on the line called the focus. Oh man, that is a mess. What's going on? So it's trying. Before, you've always said, what's a parabola? Us, the U thing. But how do you define a U? And like, what does that mean? Oh, the important things that they have is they have that directrix and the focus. That's what's defining the parabola. But it's not actually on the parabola. Axis of symmetry cuts it in half. Got a sip of coffee. And then P is actually that P value that shows up right in here. And that's the one that's like right on the axis of symmetry. So it helps us figure out where that focus is and where it's related to the directrix. Now it has one more thing that I really, really like. This is my favorite thing. There's this other one. It's a line that passes through the focus and is parallel to the directrix. And it has like my favorite name. I think it's really funny. And I made it brown on purpose. It is called the Lattice Rectum. Get it? Cause like a rectum, like in a butt. And it makes me giggle every time. So there's this lattice rectum, stupidest name ever. So, and I'm gonna make it brown every time. Don't you worry. I will always draw it brown. It's this line that passes through the focus and kind of tells us how wide our parabola is. So it tells us it goes in and out like a rectum. Oh boy. So we've got this parabola here, and we want to find the focus, the directrix, the length of the lattice rectum, and then we're going to graph the thing. Now, right now, it's not in standard form. It's close, but it's not quite there. And we really want them to be in standard form. When they're not in standard form, it's really difficult to graph them and identify what all the things that we got to do are. So we always want to turn these things into standard form. Now you'll notice there are two standard forms. There's the x minus h and a squared and a bunch of other stuff, and a y minus k and a squared and a whole bunch of other stuff. So when you're determining, are you going to use all this top stuff or all this bottom stuff, you look at what's going on for parabolas. You look at what's going on with the squared. Who's being squared? Y is being squared, like this one. We don't want this one because on here, y is not being squared. So we want the one where y has a squared on it. So we want it to look like this one. And that'll tell us where all our things are supposed to be. So underneath it, I'm going to write kind of a skeletal version of it. So there's a y minus and an h. I don't quite know what that is yet. I'm going to just kind of get everything else going. There's a 4. There's some p value. I don't quite know what that is yet, but I'm just going to leave a space for it. There's an x minus a k. I don't really know what that is yet, so I'm just going to leave it. And then there's no squared at the end of that thing. So there's always this for parabolas. We got to figure out what P is, we got to figure out what H is, and we got to figure out what K is. So for now, it's going to be a little simple. Like we've got this y squared. There's something right here going on. So y minus what is going to just be a y. Y minus what? It's just going to be a y. Oh, y minus 0. Y minus 0 is still y. So I could put a 0 here and not change anything. Boom. That's what H is. Then we go on to, actually, I think it's K. Is it K and not H? Yeah, it's K and not H, excuse me. Then let's do the same thing with X. So we've got just a regular old X right here. So X minus what is going to be X? Same trick, 0. Now right here, we got a 4 times something. 4 times something has got to be negative 8. So 4 times what is going to be negative 8? Oh, negative 2. So now this equation matches what's going on with our conic summary page. We can see y minus k equals 4 p x minus h. So that's all lined up. I can easily see what my h, my p, and my k are. So here is k, here is h, and here is p. I couldn't see that before. Now we want to go through and do all of the little formulas that are right here. I'm going to use all these bottom ones because I made it look like this one. I would use these top ones if I was making this one. One thing that I'll always use is this vertex. The vertex is always the same. It's always just HK. So I'm going to write that one down first. My vertex is at 0, 0. All right. My next formula is the focus, which is h plus p comma k. And I like to color code these. If you've got like colors or something, I really recommend having colors because it makes it a lot easier to work with, and then you can kind of tell what's going on. Or you can just label them. I always label them too and do colors. All right, so my h value is 0 plus my p, which is -2. 0 minus 2, that's -2, and k is still 0. So there's my focus. Next, I'll do Directrix. So my Directrix is at x equals h minus p. So x equals h, so it's 0 minus p, so it's 0 minus -2. So x equals 2. All right. Finally, we've got our axis of symmetry. Axis of symmetry is easy. It's y equals k. So our k value is 0. So my axis of symmetry is at y equals 0. All right. Ooh, one thing I also forgot. Almost forgot my favorite part. The lattice rectum. The lattice rectum is equal to. It's going to tell us the length of the lattice rectum. It is 4 times the absolute value of p. 4 times the absolute value of, in our case, -2. So 4 times the absolute value of -2. Uh, 4 times the absolute value of -2 is just 4 times 2, which is 8. Now, the last little bit, now remember, we're still doing the bottom stuff, like the lattice rectum and the vertex are the same whether we're using the top chunk of the box or the bottom chunk of the box. Since we're going to use the bottom chunk of the box, we've got p is greater than 0, it should be opening to the right. If p is less than 0, it should open to the left. Our p value is -2. Whoa, our p value is -2. So p is less than 0, so it opens left. All set. Now we're going to go through and we just have to graph all this stuff. I do all of this stuff, like write it all down, and then I start graphing. Once I have done everything, now it is time to graph. So I'll start with the vertex because that's easy. So our vertex is at 0, 0. I'm going to put a point right there at 0, 0. My directrix is at x equals 2. So I know that's a vertical line. So I'm going to go to 2. And I'm going to draw a vertical line here. I'll just do it by hand. It's going to use the fancy straight line tool, but oh well. So there's our directrix. We should have an axis of symmetry, which is y equals 0. So it's just right on the x-axis. Y equals numbers are horizontal. X equals some number is vertical. Next, we got to figure out where our focus is. Our focus is at -2, 0. And you don't have to do them in this order. This is just the order that I'm graphing them in. Doesn't super matter. Now, the length of our lattice rectum, oh, what's going on? The length of our lattice rectum is 8. So, and it should be equal. Like it should go, it's not that it's going to go up 8 and down 8. It's the full length of the lattice rectum. I'm still giggling about it. The full length of the lattice rectum is 8. So it should be up 4 and down 4 from our focus, not up 8 and down 8. You got to take the full lattice rectum, cut it in half, and that's where your focus is going to be. So we're going to go down 4, 1, 2, 3, 4, and we're going to go up 4, 1, 2, 3, 4, and that'll be the two ends of our lattice rectum. Whee! Okay. And now we want to make sure it opens to the left. So we want to make sure it's going this way. So we're going to make a parabola whoop, right there.